Measuring and calculating density. Density is a important intensive physical property of a substance, and it's the amount of mass per unit volume. So how much mass are we sticking into amount of space? And it's going to be a derived unit because it's not something that can be directly measured. You have to do a calculation in order to determine a density. The picture down here on the left is showing that these particles are much more closely packed than the particles over here on the right, which means that on the left it should be a higher density than those on the right, as long as the particles are relatively the same individual masses. And on the right, we can see an application of how density affects substances. If you layer them together, the more dense you are, the lower you're going to be in a column. The less dense you are, the closer you're going to be to the top. Why do we care about density? We've already mentioned it's an intensive property, which is useful for identifying unknown substances. It's really easy to look up density in a resource. You can search known densities of liquids, and you could come up with a table of a lot of different densities, or you could specifically look for an item, and the density will be easily found on the internet. Lastly, it's also easy to measure. Simply measure a mass using a balance, and then measure a volume either with a ruler or a graduated cylinder, and then you can use your formulas to make those calculations. So the density formula, you need to know this. D is equal to m over v. D is density, m is the mass, v is volume. We normally measure mass in grams and volume in either milliliters or in centimeters cubed. The volume calculations, if we have a liquid, we can directly measure the liquid, but if we have a solid, we're going to need to figure out the volume of that item using one of three techniques. We can either measure with a ruler or something similar, using the formula length times width times height. For a regular prism like a box, we could use the cylinder formula for a cylinder like a soda can's almost a cylinder, so you could figure out the most likely volume or a reasonable volume for a soda can by using v is equal to pi r squared times the length, where pi of course is the key pi, it's the 3.14, etc. I do want you to use the pi key. R is the radius. A radius is half of a diameter. So if your diameter is 10, you need to divide that by 2 or take it in half, which is 5, and that's squared, and times the length of the object. Length and height would be synonyms for each other in this case. It just depends on your orientation of your cylinder. And if you have an irregularly shaped object like a pine cone or an acorn or a object that we don't happen to know the formula for, we can use something called the water displacement method, where we're going to get the volume of the object by taking the volume of the graduated cylinder after we add the object, subtract from that the volume of the graduated cylinder before we add the object. So if you have your 2 volumes of water in the cylinder, the object's going to make the volume of water increase. It's going to make it go up. The amount that it goes up is equal to the volume of the object, and this is the math we use to get there. I'm going to show you some math problems and the process by which we're going to solve this. So you see that we have this math problem. How do we orient ourselves to this math problem? So I have some steps. I want you to always, on your work, identify what you know and associate that with a variable. So I'll show you how we're going to do that. I want you to show off your work. I know a lot of this is calculator work, but if mistakes are made, it's easier for me to find where your mistake happened. And that's just good practice. It helps you stay organized and prevent mistakes by showing your work. Finally, don't forget to box your answer and include units when you're done. So the first step is to identify your variables. Has a mass, a volume, so that's a V, and what, so there's our question word, is the density. So we're trying to find density, which means we need to use the formula D equals M over V. So worth noting that if you were to draw a heart, I like density a lot. In fact, I might love it. So cut the heart in half, you have an M over a V, an M over a V. What's not to love about density? Then you're going to sub in your numbers. So D is equal to the 92.69 grams divided by the 9.62 grams. Oops, excuse me. That would be milliliters. And if you solve that, you're going to get 9.6351 as your number. If you're in honors or regular chemistry, you need to think about sig figs. So you would need to have 3 sig figs here, 3 place values. That's right here. So 3 is followed by a 5-1, which makes this equal to 9.64 unit grams per milliliter. But since this is a metal object, grams per centimeter cubed would probably be more correct than milliliters. Number 2, we're given a length and a width and a height. It doesn't matter which order you have these because it's the multiplication process. You have a mass. What is our question word? Question mark density. So again, you're going to be using d is equal to m over v. You need to get your volume first since that's not directly provided. We're going to use the formula v is equal to length times width times height. So volume is going to be equal to 3.55 times 2.11 times 6.42. And that's going to give you 48.089. If we had to stop answering the question right there, we would round it to 48.1. And that's important to know so we can think about sig figs. I'm just going to show you how that all works. So our calculator at the intermediate problem of determining your volume gives you this value. If we're going to answer, we would have 3 sig figs from any of these measurements. But we're not done at this point. So centimeters cubed. We need to solve for the density. So take the mass that we already identified, divided by the volume. Now I'm not going to actually plug in the 48.1 in the math. I'm going to use the unrounded number because we don't want to use a rounded number in the middle of a calculation that promotes rounding error. So 45.3437 divided by, and I want my answer, so I'm going to hit my second key and then the A and S, which is down the minus. You'll see on the screen it says answer. Now I'm going to get 0.9429. We had 3 sig figs from up in here, which gives me 0.943 grams per centimeter cubed. Box that answer. Problem number 3, it's telling you a diameter. We can't use a diameter, we can use a radius. If we divide this in half, so divide by 2, and that's a radius. Here's our height. If the mass of the cylinder, so that's m. What, question word, is the density? Solving for density. D is equal to m over v. First solve for volume, pi r squared. So I want you to use the pi key on your calculator. We need the radius, which 2.4 divided by 2 is equal to 1.2. We need to square that, as it says in the formula, and then multiply by the 5.75 centimeters. If you do that process, you need to use the pi key, so that's right on your calculator, times the 1.2. You need to square that thing, times the height, which is 5.75. And you get this number in your calculator, which we want to save. And again, our initial problem gives us 3 sig figs in the radius and then 4 sig figs in the height, so we only would have 3. If we had to answer right now, we would get 26.0 centimeters cubed. And that's just the middle step we need to solve for the density. So we're going to take the 30.148 grams, divide by our answer, which is again 26.0. But we're not actually going to use that. We're going to use the ANS key. So I'm going to type in my mass, 30.48, divided by my answer, second key, minus. And it says answer. And I get a density of 1.1589. We already said 3 sig figs from your radius, 1.16 grams per centimeter cubed. Again, if you're in chemistry fundamentals, sig figs are not going to be important to you. Last problem, an irregular object. So that's going to tell us we're going to use a different formula. It says a mass, so M. It's telling us we're using a graduated cylinder. We have original water volume, so this is before, volume before. After the object is placed, the water goes up to 60.8, so that's your after volume. Density is question mark. D equals M over V. Our volume is the volume after minus the volume before. So 60.8 milliliters minus 31.50 milliliters. Volume equals 60.8 minus 31.5, 29.3. That needs to be a 0 because the subtraction rule says the least accurate place value. The least accurate place value is the hundredths. That's the place value for this left, or for this right in both of those. Not our final answer. D equals M over V. So the 214.796, we already identified that, divided by the 29.3 milliliters. 214.796 divided by 29.3. That gives us 7.33092. We have 4 sig figs in our volume, so we get 4 here. The 0 followed by 9 rounds up to 7.331 grams per milliliter. But since this is a solid object, it should probably be grams per centimeters cubed instead.